Okay, welcome back. So here's the sticky problem. Fox and Rabbit don't have a common superclass. They implement very different behaviors. So what are we going to do? Well, we're going to make a superclass. Both foxes and rabbits are animals. So let's create a superclass called animal, because every animal has an age. It knows if it's alive or not. And it knows that it has a location in a field. Instead of using run or hunt, let's rename that method as act. So if a fox acts, it will hunt. If a rabbit acts, it will run. With those conceptual changes, simulator is now decoupled from the two classes that are implementing the specifics of the predator and prey. For instance, the loop inside of simulator now says, give me an animal. Animals, give me your iterator. Iterator, grab the next animal, have that animal act, and that animal should do whatever it is that animal does. And that animal could generate new animals. So in this case, I might get back foxes or I might get back rabbits, depending on which class animal happens to be through polymorphism. And then if the animal's not alive, remove it from the simulation. So instead of having two different collections, we have one collection of the superclass animal. But we do have a bit of a problem. See, animal. We know how a fox should act. We know how a rabbit should act. But we also know that animal, because it's going to be a static type, right, an object of type animal, needs to have the act method declared inside of it. But what does it mean for any general animal to act? And more importantly, if the subclass doesn't override it, would that action be meaningful? The way we get around this conundrum is that we need to tell the subclass that it must override. The way we make something require to override a method is by making that method abstract. See, one more time, this line right here, animal.act, the compiler only knows it's an animal object. So act must be declared an animal to satisfy static type checking. But there is no common implementation. So we need the dynamic type to be something other than an animal. The keyword abstract does this for us. Abstract act. So it gets put in front of the access modifier. Act will be public, it will be void, it will take a list of animal objects, or we have a list of animal objects which will be populated by act, which will produce new animals into the simulation. The thing with an abstract method or an abstract class, if you have an abstract, let's try this again. If you have implementations for everything else in your class, but one method is abstract, the entire class is abstract. An abstract method sets up a contract. It specifies that this is going to be the return type, this is going to be the access modifier, this is going to be the name, this is going to be the parameter list, but it has no body because it's just saying this is what must be, but it's up to the extending class to say how that extending class does it. As a result, if a class is abstract, you can't make an object of that type. You can make a variable, but you can't use the new operator because if the class is abstract, it doesn't have all of the pieces to exist. So what has to happen is another class must extend that class and then implement the abstract methods. Once the abstract methods are implemented, we call that a concrete subclass. If the subclass doesn't implement the methods, then something must extend the subclass. Eventually, somewhere, all the methods have to be defined. Well, if we have the animal class, public abstract class animal, abstract public void act. If you have a method that's abstract, you must include abstract in the class definition. Now, all the other methods is alive, age, all of that stuff, all of the things that can happen to the animal, those can all be implemented. But this one just has a semicolon. But the simulation will work now, if you look at the next iteration, because you have concrete classes fox and rabbit that have act methods that tell the simulation what those classes will do with the dynamic type. Once we have this notion of abstract classes, we can extend this to further levels of abstraction. Farther down the hierarchy, we have the things that actually do the work, but higher up in the hierarchy, we have things that specify more, I was going to say, abstract concepts. The simulator is made up of actors. Some of these actors are animals, which will act like rabbit and fox. Another actor in the simulation could be a hunter. Now, you could say it's rather speciesist to have the hunter, which is a human, which is an animal, broken out outside of this. But the purpose here might be, we could specify that an animal hunts only until its hunger is sated, whereas a human hunter will sometimes just kill for sport. So, in terms of this simulation, I can see where they might break the hunter class out and make it a separate actor. One other thing to note, the extends is represented by the open-headed arrow, so we can see that there is the inheritance hierarchy here, and we can see that in this instance, every class has one and only one parent. But what if we had a situation, or we wanted a situation that was like this? We want certain things in the simulation that have to be drawn. We want certain things in the simulation that have to act. So for instance, the rabbit and fox and the hunter need to show up in the simulator view, but we're also simulating the impact of all of this activity on the ant population, but we're not going to draw those. How do we get this to work inside of Java? This doesn't seem like it could possibly even exist. Hold on to that thought. We'll come back to it in the next lecture.